Folks, I'm going to give 2 more minutes for the latecomers, and we will start shortly. Hey, welcome everyone. Is there anyone who does not have a user and password, did not get a card from me? Okay, perfect. So we're here to talk about effectively running Python applications in Kubernetes and OpenShift. But before we get to that, let me give you a few questions. I want to figure out how much you know. How many of you heard about Docker? Awesome. How many of you heard about Kubernetes? Awesome. How many of you heard about OpenShift? Awesome. How many of you use Kubernetes? Okay, and by the end of this workshop, that will change significantly, I hope. Okay, let me catch up with the 2 new persons. Hey, welcome. So throughout the next 3 hours, we are going to create a Python-based app. And the entire workshop and the materials for the workshops are available under this URL, tutorial.apps.pycon.pixie.io. So either you can follow me talking and going through the presentation, or if you're comfortable, you can just read and go by yourself following the documentation. The documentation is descriptive enough to go through the workshop, and additionally points to necessary documentation pieces in Kubernetes or in OpenShift, whereas I'll be explaining in details every single piece of the software that I'll be deploying or working with, or helping you how to debug applications running on OpenShift. So whichever option you prefer, you're fine to do. If you have any problems, questions during the workshop, just raise your hand, or you can ask the questions, and I'll either come by and help you with the problem, or Graham will help me, or we'll try to debug together the applications. The new 2 persons, welcome. Here you go. And you are the other one, right? I think we're still missing couple people, but okay. So let's get this thing going. For those of you that know what a Kubernetes is, okay. Thanks. So Kubernetes is basically an open source container orchestration platform, which in the simplest term means you have a Docker image with your applications, and Kubernetes allows you to nicely run your application in the cloud. That's the simplest possible information. And what OpenShift is actually an enterprise distribution of Kubernetes. Similarly to what we have a Linux, and then there are different distributions like Red Hat Enterprise Linux, there's Fedora, there's CentOS, there's Ubuntu, there's Arch Linux, or whatever other. Each company adds some nice bits to its distribution, and on top of that builds his product. This is how OpenShift was born. So let's go quickly through the OpenShift architecture, because that's probably the easiest way to understand what both Kubernetes and OpenShift is. And although I think I missed one thing from the previous slide. Let's go back slightly. Give him some time. I had a nice picture down that session, which depicts the differences. So, as I said, Kubernetes is the actual mechanism responsible for managing your containers, for scheduling them on nodes. So what OpenShift adds to that is the entire platform as a service capabilities that we already built into OpenShift previous versions, and we brought up this into the container world. So that is the builds, the routing layer, and the packaging. Okay. That's the picture that I was missing. Give him some time to load. Okay, so the bottom layer is obviously their operating system. OpenShift or Kubernetes can run on any kind of environment that you can think of, be that a bare metal, be that Amazon, GCE, or on-premise. On top of that, there's an operating system. In my picture, that will be RHEL. And the blue boxes, the 3 layers of blue boxes, this is where the Kubernetes is, which is container management and scheduling part of the entire stack. Whereas OpenShift, as I said, is the build platform, the deployment operations, although we managed to upstream several of the deployment capabilities to Kubernetes. the service catalog, and the self-service, which you will be working with through a web console. Okay, now we can go to the architectural land. And of course, the web is not cooperating. Okay, so the two most important components of every OpenShift or Kubernetes clusters is the master and nodes, and that will be shown in the picture nicely. The master is the brain of the entire cluster. This is where the API server that you will be playing with is placed, and additionally, all the controllers which are responsible for going through the life cycle of each of the resources will be are provided. And the other part of the stack is the actual nodes. The nodes are the compute resources for the cluster, which is where the actual application is being run. And obviously, you can have both of the nodes will be the thing that you will have in as many number as you are comfortable of, or how much you need. And the master node is can be easily set up as a full high availability place. So that is the two most important pieces of the OpenShift. So how the entire thing works? Okay, now we have half of the picture. The other half shows pretty much the same thing. So on the left, we have the master that I talked about. On the right, there are nodes. We have three. The three are yet to be shown in a few seconds. And there is a routing layer, the persistent storage at in the back. And I think I remember that's the majority of the pieces. So before we move forward, I would like to introduce a few of the terms that will be necessary throughout the entire rest of the workshop, and then that I will be using in the workshop, and so that you can feel comfortable with. So the most important piece in the in OpenShift and Kubernetes world is the namespace. The namespace is a grouping primitive that allows you to put all, well, it's not a grouping primitive, it's a place where you where you will put your all application. It allows you to manage who has access to which namespace, where all your application will be running. And within each of the namespaces, which in OpenShift is a project, and I'll explain why OpenShift decided to build on top of namespaces in a minute, we will be actually running our applications. So the smallest piece of unit that is running in OpenShift is the pod. The pod is, in majority of cases, one-to-one mapping with a container, but it doesn't have to be. A pod can be one or multiple containers, but from my experience that I was deploying different application in OpenShift, in majority of cases, it is always one Docker container is one pod. But there are possibilities that you can have multiple containers being part of one pod, and that reason might be either some kind of monitoring that you can have along with your pod, along with your main application, or some additional diagnostic tools that you can deploy together. So the pod is the smallest unit. The second important piece of the entire puzzle is the labels. Labels allow grouping resources together. We put a label on different resources, and based on that, we will be able to figure out that this group of pod that has this particular label will be creating a service. So a service, on the other hand, is a stable point for accessing your applications. Like I said, pod is the smallest unit, and they are brought up and down as needed depending on how many replications of your applications you want to have, how many instances of your applications. So they will be brought up and down. And additionally, you can scale it up and down. And if a pod dies, a new one will be created in its place. And the service will provide always stable access point to all the backing pods. It'll be so much clearer when we will be deploying our first application. So hopefully that will make sense at that point. So we covered the pods, we covered the nodes, labels, and an important also information along with labels is label selectors. These allow us to define how the selection process is happening through the labels. And one final piece of information is the replication controller. Like I said, pods can come and go, but manually managing the pods will be cumbersome. That's why a replication controller is responsible. This is the first controller that you will be working with. Its responsibility is to make sure that at any point in time, there are always this many instances of your applications, this many pod of your applications running at all times, always. So that means if we manually add a pod that will be selected as part of this group, a replication controller will pick that, oh, this does not belong because we want to have 3 and then suddenly are 4 running. It will kill one of those pods. And throughout his life cycle, if it figures out that there's not enough pods on the other hand running, it will bring up a new one to replace the one that died. And I'm hoping that I covered all of the places. Oh yeah, there are 2 other resources that are important and will be used throughout the rest of the workshop, which is the route, which allows exposing services to outside world, because services only expose the application inside of the cluster. It does not go beyond that. And the event provides you information about errors, problems, warnings that are happening in the cluster with your resource. For this workshop, we will be using a environment that Graham kindly provided to us and the entire OpenShift evangelist team. You've received the URL for the server. I've also asked yesterday in a note to download OC client. I do hope that you managed to do that one. If not, in the next section we'll get to that one in a moment. You will be provided with the links to the OC client. We will be interchangeably using the web console and the OC client binary. The reason for that is the web console provides nice user interface, but unfortunately it's usually a little bit behind the OC client, and that's because everything that is done is usually done from the command line. That's why the web UI team has to catch up with so many moving parts at the same time. You got the user name, and the password is exactly the same as the user you've used. So go ahead and download the OC binaries for your stations and try to log in into the OpenShift cluster. I already have one.
I know, but not for the people who don't.
Who doesn't have? You have that one for Mac? Graham, the other one is for Mac, I guess. I can in the worst case, I'm going to build the binaries. It will be definitely faster than the 20 minutes downloading part. Okay, as soon as you get the binary, I'll try to move forward slightly so that we are able to not to stop in a moment. So for those of you that already have the binaries, you can try OC version. That should give you the information about the current version of the OC binary that you have installed. In my case, it's running OC v1.5.0. And that will be probably the same version that you should be running. It both tells you about the version of the Kubernetes that we have behind the OpenShift and the OpenShift itself. If there are any questions at this point in time until we get the OC binary running, I think we can answer them. Are there any questions, doubts, problems, aside from network? Does anyone need the Linux one? I still have the key for the Linux one. Don't be afraid. Okay, cool. Don't be afraid. You can. That's Windows. Cool. Don't be afraid to ask questions. For the most active attendees, I have some rewards. So I'm not biting. I really, really like for you to actually get something from the tutorial. And although I'm a little bit stressed, okay, that's the laugh that I needed. Thank you. Okay, I'm gonna give you additional minute or two, and then we will head off to actually trying to deploy the application. Or maybe in the meantime, since I'm waiting, the next piece of advice that I can give you is we are providing you currently with an environment where you are able to run the OpenShift app. If you're, on the other hand, would like to give it a try on your own, at home, at your own laptop, there are three possibilities how you can run OpenShift. First of all, there's OpenShift Online, and that was announced about 2 weeks ago during the Red Hat Summit in Boston. That OpenShift Online went public officially, so it went out of the dev preview, which it was. So that means that anyone can get an access to OpenShift Online. We provide you with a 1 gigabyte of memory and storage for running your application. Unfortunately, the application that I created today is a little bit heavier than that, and I failed deploying my application very fast. The other two alternatives, which you can use locally, is the Minishift. Minishift is a VM instance with pre-configured environment, or additionally, there's a development option, which you can go through just taking the binary and do OC cluster up, but please don't do it right now. The reason for that is OC cluster up downloads Docker images that are needed for running the OpenShift instance, and it just literally runs it runs all in one, meaning both master and node runs as a Docker image, and additional options, and it all runs in a Docker environment. That's why I'm not asking not to do it right now, because you're gonna kill the network entirely, and we don't want to do that because we obviously want to finish the workshop. So I highly recommend that one if you want to give it a try at home. Probably the OC cluster app is the simplest one that you can come up with. Once obviously the first OC cluster app will take a little bit time because it needs to download. If I remember correctly, there are 3 images. I can either, and of course it stopped. I'm not sure if I have those locally. No, I don't. So yeah, that's probably the easiest. option to run OpenShift. Do we have the binaries running where everyone able to run OC version and it showed what I got there? Meaning we got that? Perfect, awesome. Is there anyone that did not succeed with that? Don't be afraid, okay? Do you need the binary still?
What's going on? Yeah, I don't know.
Tutorial apps, PyCon, pixie.io. Do you have the cookies enabled? Maybe it's because this is just the, yeah.
All right, try that.
I personally use, I always have cookies disabled for different pages. That's why I'm asking. I don't know. I'm not 100% sure. Okay. In that case, tutorial.apps.pycon.pixie.io. Well, it started working because Workshopper is the thing, but I'm not sure why it
Tries, but that's all it gets. Yeah, I'm sure.
Do you have a different browser? Can you give it a try with a different browser?
Yeah, I'll give it a whirl.
You're using Chrome, maybe, by any chance?
Yeah, I got Chrome. I got it to work on.
And got it working.
Firefox wasn't working. It took a while for this to come up earlier, but
Yeah, I know, because I have the same problem. It took me a while to go Okay. I can't complain. It's working just like that this time. Okay, so let's go ahead and look at the architecture of our application. It's almost fits in one screen. We have 5 parts, which are actually 8 of them. The first one, and we will start with that one because that's the least interesting part, is the UI. I built a, the most important thing. We are building a web search engine because we want to be the next Google, right? I come up with a fancy name. It is called The Blast. I hope you like it. So there's the web UI. It's a React application. It connects to 3 backends. Each of the backends is responsible for a separate piece of information. One is the text, the other one is video, the third one is images. Each of those backends contains a separate database instance. There are 2 MongoDBs and 1 PostgreSQL, and the reason for PostgreSQL is because I was not able to store images in MongoDB. And the most in the back element is the scraper. Currently, the scraper is implemented just for one of the backends. So, and you'll see that in a moment. It will feed in the database, the text database, with some data. And we will try to build the entire application throughout the rest of the remaining part of the workshop. And I'm hoping we will manage to at least do half of that. Okay, the most important thing, you have OC version running. Now it's time to log in into the web console and the CLI client. So what you do is you invoke OC login. The easiest is to copy paste that one. And we're hoping for good. And the user, the server is brought up with a insecure certificate because it's a self-signed one, so don't be scared. You just need to say that, yes, I'm okay with using insecure connection. And the username is the one that you were provided with. The password is the same as the user, if I remember correctly, right? Right. You got all the way to close 30. I'm going to take user 33 because why not? Upon successful login, you should see information that you do not have any projects, which is obviously the truth. And this is the command that you can actually use to create a new project. And let me go back to the project topic that I was talking before. Remember when I mentioned that a project is something like a namespace in Kubernetes? The reason that we created a project resource on top of namespace is that we want to provide a better, finer-grained control over what a project can or cannot do. By default in Kubernetes, everyone can create a namespace and everyone can access any namespace, which is obviously in a multi-tenant environment not desirable. You want to be able to limit people to actually use this one particular namespace. And this is where projects were created for. Additionally, a cluster administrator, OpenShift cluster administrator, can limit how a project will look like. You can provide a template how a project will look like for the users that are for you. There are, as I said, there are links. I don't want to get too much into details because that will be so much waste of time. And we want to actually do some stuff, right? I want to hear some yes. Yeah. Awesome. So one thing is logging into the OC using the OC binary, and the other one is actually accessing the same site from the web console. So if you go to the same address that you just saw, console.pycon.pixie.io on port 8443, don't forget the HTTPS, you will be presented with a nice login page for the web console. And here again, you're using the same credentials. In my case, it's user 33. Yeah, I know. I've talked with Jessica. There are some issues with Safari. I'm not 100% sure why, but there are some weird issues. So, project names or namespaces names are unique in the entire cluster. That's why if two users will try to create the same name, that will fail, at least for the second and the following persons. So for this workshop, we are going to create a project name that is the same as your username. So please create a project by clicking New Project. And for the name, use your current username. In my case, that was user33. You can put some fancy display name in the description if you like, but I don't care much. What again? If you OC login, the URL is console.pycon.pixie.io 8443. Don't forget the HTTPS. Yeah. Is there anyone who had problems with logging in into web console or the using the CLI? Awesome. That was the easiest part. Now the fun part starts. The front end. So the easiest thing that you can do at this point in time is just copy paste the OC new app, and I'm going to explain bit by bit what it does, and it'll be so much easier to run. The reason for why we are using the console and not the web console, the CLI and not the web console, is that the new app allows me something that is not available in web console yet, and I'm going to talk about why in a minute. So just copy paste that one. This will create several resources, and I'm going to talk about each of them one by one in a moment. Okay. There's one problem that I ran into. So I did not log in, or I did not specify any project in the CLI, and you might probably run into the same trap that I did just now. So you need to switch a project or pick a project in the command line, and you do that with OC project, and my project name was user33. And yes, if you, yeah, that's the reasons where you're using both of them, you sometimes need to catch up. Okay, so why we use the CLI instead of the the web frontend? Here's the reason. If you are creating an application in OpenShift, and I'll be talking about a build in a minute, you need to provide it with information about how to build your application. In my case, this is using an image that is provided by me, which is not by default available in OpenShift, for building HTTP applications. So this is the image name that is responsible for building. And the repo URL after the tilde is where our application is actually available. If you want to check the sources of the application, you can easily do so by going to this URL, which is the entire application is under my repo. And as I said, each of the components that we will be deploying has its own subdirectory. That's why if you were paying attention, you probably noticed that we specified, sorry, a context directory. Otherwise, it would build the application from the root, and that would fail. We provide the applications with a name, and this is the UI, and we will be just using the component's name accordingly for each of the pieces that we're deploying. And we additionally added labels to the application. We will be creating a similar, the Python application in a minute from the web console, and that will be so much easier because we don't have to provide the labels. That is done manually, automatically by the web console. And it will be so much easier to specify which image we want to use for building the application. So having to look at the list of resources that were created for us, there's quite a lot. So we see 2 image streams. We see a build config, a deployment config, and a service. So let's go one by one. What does it mean? An image stream, you can think about an image stream as a Docker repository. How many of you know what a Docker repo is? Yeah, obviously. So either you can use image streams or Docker repositories. But the reason that why we're using image streams is that image streams provides a stable endpoint for stable information about Docker image in a specific point of time. Obviously, you could do that with Docker, but that will require you to use a specific Docker image ID, where majority of cases people are lazy and prefer to use light HTTPD CentOS 7 latest. That's obviously because we want to do. But the problem with that is that if the image author pushes a new version, it might break your application, which will not happen with image stream because we pinned the image to a particular version. Additionally, which is not what is not possible through Docker images, is that we support image change triggers. The image change triggers are for the platform to be able to notify different components, different resources, that the source image has changed and a new build should be triggered or a new deployment. And we will be working with that in a minute, because by default, whenever we are creating the application either through OC new app or through the web console, the image change triggers are configured for us. So in this case, as soon as the application will build, the deployments will be notified that there is a new image that should be deployed, and it will deploy. We don't have to interact with the process manually. And we can go even one step further, and I'll tell about that one in a moment. The build config, as you might probably figure it out, is a configuration how the build process will look like. In this piece of in this particular case, it's not that interesting because this is building a HTTP application. So we will dive into the build process in a moment when we will be building a Python application, because that's what we are most interested in. And the deployment config, as you might already figure it out, is a information how our application will be deployed. So if we look at the web console, once again, we should see the application already there. So, and as I said, and the final piece that I did not mention, but it was listed, is a service which is exposing the UI application internally inside of the server. But obviously, we want to be able to access the application from the outside. To do that, we are going to expose our service as a route. So what we need to do is use OC expose. Then we need to provide the resource name, resource type, and the resource name. I didn't mention that before, but how you interact with the OC binary. As you probably notice, OC binary has 3 pieces. One is the OC, then there's the verb that allows you to invoke action. The actions can be expose, get, describe, delete, and a lot more. Then after that, there will be always the resource type. In our case, this is service. It can be deployment config. It can be a full name of the resource, or it can be an alias. In my case, I use SVC alias, which stands for service. I could use OC expose service /UI or space UI, works the same. And as the final component, there's always the resource name. If you don't provide the resource, yet the resource name, it will assume that you want to expose every single service that is available in your project. So I can, for example, do OC get, and it will tell me all the different resources that I can have. So if I want to see what the build configurations that I have, OC build configs aka BC. Let's do OC get BC. And that will provide me with the information about the build configs that I have available. Obviously, there's just one additional nice feature and very useful for daily use is OC describe. BC, I'm going to add a name because I don't care about more than just one. And that will provide me with a more descriptive information about my build, which failed, by the way. But then it's working. In the same way that we have the build configs, because build config is just a configuration of your build. From that, we create the actual builds which are responsible for invoking the build process. So you can do OC get build to get information about the builds that happened. You can the same information. Okay, I have two different information from different pieces, but whatever. So we have the build succeeded. If we go to the web UI, instead of create route on the right upper corner, we currently have the route under which our application is being exposed. If we click that one, this is our last applications. Is there anyone that did not succeed in deploying the web UI? Are there any questions? Yeah, sure.
I was having network problems, but
Yeah,
I missed out on the code to actually, after I create the project, the code to build it.
Can you? Yeah, sure.
And I can't load that page either.
Can you go to my GitHub? Let me bring the entire block once again. It might be easier. Sure, no worries. It's just a network. The problem with the block is that it's lengthy. I'm trying to fit it in. Yeah, you don't forget to put the slashes at the back of there. You can drop the .git part. Are there any other issues? Questions? Can you show me the OpenShift console? It usually opens in a new window. Overview, yeah. Give him some time. I think you mistyped. because your project name was
Oh, you dash. No, you're right. Yeah, I think.
you used a different project name than the one that I assumed.
Yep.
Yeah. Are there any other problems? Were you able to? Sure, go ahead. Take your time. We'll wait. If you find some issues with the application that I'm running, that I've created, I'm open to issues. PRs are always welcome. So it's a very simple application. There's just some Flask RESTful APIs and one scraper. So very simplistic, but the reason for that was I want to have something short and easily graspable. So there's no magic going on in between. You got that one? It's getting in. Okay, cool. So now that we have the we covered this pieces, we covered that piece, the probes. This is the last piece that I almost forgot about. So if you go once again to the web console, and I forgot where is mine, you will notice that the web console will suggest you that you create health checks. So OpenShift, we want to be able to actually use OpenShift capabilities of monitoring your application. To do that, we can create two types of probes. There's liveness probe and there's readiness probe. The difference between the two of them is that the first one will check if your pod is actually alive, if it should be promoted to the next life cycle. And the later one verifies if the application that you have running in your pod is ready to take requests. So if you fail the first health check, it will destroy the pod and create a new one instead. If it fails the second check, it won't mark the pod as ready to serve your application, which will be noted then in the service. It will not the service will not route any traffic to it until it is ready. And obviously, we can either create the liveness and readiness probes from here by clicking the link that is provided, or again using the web, the CLI, whichever you're comfortable with. So I'm going to use the CLI because I'm the person that I usually use the CLI. And the liveness probe that I set up is for 8080 port, which is the port at which Light HTTPD server is listening, whereas the readiness, it tries to get a URL from the server. So the first is a TCP connection, open connection, to make sure that the server is up and running, and the second one is actually trying to access the application that we just saw. Does that make sense? Sure. There's a separate component that is responsible for metrics, and if you have that one deployed on OpenShift, then yeah, you will get those information. You can get those information from the metrics backend, but it's a separate application that you deploy on OpenShift. Unfortunately, for some reason, it's not working in the environment that we have. We tried. Graham tried really, really hard, but I know that for some reason it is failing the installation process. If you go to the OpenShift online, it does have the metrics enabled. So you can. Okay, Since we have the UI, which is the most boring part, let's jump off and try to deploy the first backend. So, like I said, we have a Python application, and that's a Flask RESTful, very simple. It just connects to the backend database and returns the information matching the search criteria. But this time, to make it fun, we will try to use the web console to deploy the application. So we will pick Add to Project. From the Browse catalog, we will try to match an image that is capable of building a Python application. We just need to wait a moment for the catalog to get back. We pick Python. By default, we provide several versions of Python. I wrote the initial bits of the Python builders, and at the time that was 2.7 and 3.3, but currently there are a lot more than that. We will use the first one, which is using the latest version, which is 3.5. We didn't got to a 3.6 yet. Coming to that one. Once we select that, we now need to configure how our application will be built. So, as the name, pick text. Please be very careful with the naming. There are certain connections between the services that I have, how the application is being configured. So picking a different name might break it, and I'll be pointing to those. As the repo, we are using the same repo as before. Don't forget to click the Show Advanced. The advanced options allows us to configure additional options. What we care at this point in time is the context directory. The context directory has to be text. As you might see, there are other options that you can configure, such as the Git reference, meaning you can configure a different branch that you want to build your application from. There is an option to configure secrets, routing, which is done by default. As I mentioned, if you don't want to expose your application by default, you just need to unclick it. But obviously, our application, our front end needs to be able to connect to the backend, so we need to expose the application. There's the entire build configuration, and I'll be going through that in a moment in more details. Same applies for deployment configuration. You can set additional resource limits, but we're going to left that on for now. Once that is done, all you need to do is click Create. So if we go back to the overview page, our text application should be, the build process should be running. We can actually see the process clicking one or just going through builds, and let's have a look at the process. So it's currently complaining about operation not permitted, but that's not a problem. How the build process currently look like? So the build process that we are using is a process that we come up with as part of the OpenShift v2, which allows combining a environment with the source of the application. This is the name of it, which is source to image. This means that you need to provide source to image build with a builder. The builder contains the environment for your application and additionally 2 necessary scripts. Those scripts are assemble and run. These are, in case of a Python, these are very simplistic. In case of a Python, assemble, all it does, it just goes through, it just installs all the pip dependencies that we listed in the requirements text file. Or if there's a setup.py, it will try to invoke setup.py instead. Run instead will try to figure out what kind of application you're running. If it figures out that you have GUnicorn in your dependencies, it will try to use GUnicorn and deploy your application using GUnicorn. If it's a Django, it will try to run a Django instance accordingly. Additionally, at the end, you can manually specify which Python script should be the main entry point for your application. And once the build process is done, which is the push successful should be marking, let's see the overview page. Because, as I told before, the deployment will be triggered automatically out of the build. And unfortunately, it looks like the application is not working properly like we would want it to. So let's try to debug what went wrong with the application deployment process. So we look into deployments. We need to figure out the pods and look into the actual pod that is trying to run our application. It went with the crash loopback off, which basically means that it failed. Let's try to have a look at the logs from the pod. And the logs clearly state as that please set either app module, app file, app script environment variables, or create a file app.py to launch your application. This is an error that is coming from the run script that I was talking from the build, from the source to image builder image. It is trying to match the application that it currently built with the pre-configured information that it has. But it could not match the two in any possible way, so it won't be able to run. So what we need to do is we need to actually modify our deployment in such a way that we will tell it how to run our application. So we go back to deployments. Actually, environments are in a separate tab. And I don't remember the names, but it has to be, that's this. So we need to say app module. This is api.app. Once we save that one, a new deployment will be triggered for us. Like I said before, there are a few triggers configured for every single deployment that we have. Those two triggers are either image change, which is triggered whenever a new build happens and we will try to deploy the application, or the other one is a config change trigger, which means whenever a configuration change, we will trigger a new deployment. Now let's see if the application is currently running. Yeah, it's running just fine. This is the thing that it was missing before. We can ignore the warnings for now. And we can actually check the logs of the application. No, it's just fine, working. So, okay, we have one thing off the list. Are there any questions at this point in time? The application, like I said, have somewhere the sources. We build the text. The text app is very simplistic. It's just the api.py. It contains a Flask app. That's why we need to set the app module to be api::app, because that's the main app, Flask app that the G-Unicorn needs to know how to run. You can easily run that one locally as well. And the other part of this application is the actual database and backend. And that's very simplistic as well. It just tries to match the text from the database based on what you specify, right? So, okay, I need to figure out where I am. Okay, we have the application up and running, and we want to be able to leverage the same capabilities of readiness and liveness check that we had before in the text, because we want to make sure that the text backend is running at all times, right? Right? Cool. So what we will do is we will create again the probes. I'm going to try to use the web UI this time. I just need to copy paste the URL. As you probably noticed, the URL for the readiness probe does not contain the IP of the service. The reason for that is the readiness probe is done at a pod level, and obviously each pod will have a different IP address. That's why it doesn't make sense to specify this address here. So we're going back to the web UI. It also complains about the health checks, and we want to add liveness probe. I think the liveness probe is supposed to be OpenTCP, so not GET but TCP socket, port 8080, which is perfectly fine. You can additionally set some initial delay and the timeout, how much time it should wait before checks. For example, if your application takes a little bit longer to set up, you want to delay the checks in some time, and then additionally, okay, and now we need to do add a readiness probe, and the readiness probe was this one. It's HTTP GET, so the two are in place. We create those, and again, since we changed the configuration, a new deployment is being run. Let's check the overview page. We can now see a nice deployment happening. A thing that I wasn't talking before is the deployment strategy. OpenShift provides several different deployment strategies. The default one is the rolling deployment, which means we are setting up new deployments, and only when a new deployment is up and running, we will be closing slowly the old deployment. And in my case, this is one pod for one pod. So the old one will wait until the new one will be brought up. You can configure what's the percentage of the new applications running versus the old one. But unfortunately, it looks like there's something wrong with our application because it should be running just like that. Let's check our pods. One of the pods clearly states that it does not have containers ready. So let's try to figure out what's wrong with it. Let's look at the events. Give it some time. It is planned. It is planned to go through this path from the start. So we clearly get the information from the events that our application is not healthy. It states that the readiness probe failed. Why? There is a client timeout executed while awaiting headers. Okay, so there's something wrong. The readiness probe, the liveness probe went through because 8080 is servicing requests, but the readiness probe is not for some reason, which means when we are trying to get X at the end, trying to get an element with an X in it, it's for some reason failing. Let's see at the logs, because maybe the logs will provide us with some information. Could not connect to Mongo. Oh, right, because we just deployed the text backend, but we did not deploy any Mongo instance, right? That's the reason why our deployment is failing. So all we need to do is create an actual Mongo deployment. So let's do that one. So yet again, we go add to project. But now instead of going through catalog, we're going to deploy image. OpenShift provides by default several images of popular databases. They are all stored in the OpenShift namespace. Those image streams are, in our case, differently named. So in our case, what we want to deploy here is a MongoDB. We need to pick the version that we want to use. And that's it. Now we need to provide the name for our application. That cannot be MongoDB, because that will clash. We will use TextDB. And that should be all. So make sure that the name is TextDB. And create. At the overview page, that we should be, okay. We should see a MongoDB deployment happening. Again, unfortunately, there's something wrong with our MongoDB deployment. Let's go through the debugging process once again. So I'm going into the, I went into the service, which I wanted to go through the deployment actually. So let's look into the Mongo TextDB deployment to the latest version. Once again, we need to check the pods. There's some error with it. So obviously the easiest that we can do is check the log. So the log says that we are missing several environment variables. The environment variables are there for setting up the actual MongoDB instance, which is the user, the database name, the password, and the admin password as well. So what we need to do is to actually create the environment variables for this particular deployment. But since we are gonna need the same values for the text backend to be able to reach to the MongoDB, what we will create is we will create a config map. A config map is a resource that allows us to gather resources together and then reuse in several different places. So the easiest that we can go is,
It's like putting a variable in for environment variable.
yeah, well, generally there are two possible options. Either you're gonna create those environment variables at the deployments page, go to the environment and type in the environment variables. But then again, you need to remember those and need to reuse those in other places where you're thinking about using the same credentials for accessing the same database. And in our case, we will be using those in the text backend and as well in the scraper that we will be using, because the scraper will be responsible for feeding the database with data to be presented for users. So in our case, that would mean that we would need to configure those credentials in 3 different places. Whereas if we use a config map, we will have a single place. Whenever we will need to change for, I don't know, we got a breach and we need to change passwords or something like that, then there's just one place that we need to set it up. So if we're on the configure, there are 2 possible options how to create a config map. Either we will go from the deployment configuration page at the bottom, there's add config files, which will allow us to specify the configuration values, because config map can either hold direct values like we will do here, or it can hold files that you can then mount into pods. In our case, we will use environment variables and inject these values as environment variables into the pods. So either if you're comfortable with the web console, you can create config map. We need to obviously say so. Or, and that's faster because that's copy paste. Just go to the instruction, and there's very handy command that easily allows us to create the config map. Oh, important thing, the database name has to be blast_text. So we create such a config map. Either you do that from the web console and you need to type in those passwords. You can pick the values for the user password and admin password, whatever you feel comfortable with, because this can be auto-generated, and I'll explain that in a moment how to do that one. it just doesn't make it just doesn't matter at this point. The only important information is that the MongoDB database is blast_text, because that's what all the other parts of the system expect to be. We can see that the config map is actually configured, and the name of the config map has to be text as well, because the scraper expects a text config map. So that's also an important thing. If we want to see the exact details that we have in the config map, here's how we do it. We will do -o YAML, which will provide us with the full description how a config map looks like. Okay, so now we need to tell the deployment that it should pick this particular config map and use those values as environment variables. The easiest thing to do is to use OCSet environment from config map and specify the name of the config map. And then we will use identical command to set the other deployment to point it that this is the credential that you should use to run the backend as well. Now if we go to the overview page, there are deployments happening at the same time several times, but we clearly see that the TextDB backend is working properly. No more errors. We will ignore the health checks, but if you want to, you can easily create such health checks. Now let's wait for the text backend to catch up as well. We can even check the logs of the pods we want to have to check the deployment for. The reason I'm not going into deployment logs over here is that these logs will give you the logs of the deployment process and not the application that is actually running our deployment. Although at some point in time, I think it does. We see that there are gets happening every couple seconds from the readiness.
That's your monitor, right?
Yeah, well, this is logs from the pod. You can always either do that from the console, like this. So if we know the pod name, and we can get that from OC-get pods. And we know that our text deployment was text-4 means that this is the 4th instance of that one. I don't want that one. And you can do easily from here like that. The same happens. You can do even with an F that will just follow what's happening. The other cool thing is that from looking at the deployment, we can actually get into the pod itself and verify its state. Meaning there is an option terminal. Okay, I'm gonna make it bigger. Not sure if that works. And we are actually inside of the text terminal, right? So env will actually provide us with all the environment variables, which one of them is the MongoDB password that was injected from the config map. So we don't have to deal with manually specifying those environments because these are injected from a single place, which is the config map. Well, there is a different resource that is probably more accurate for using for using credentials, which is a secret. Secret works similarly to config map. The only difference is that config map stores plain text values, whereas secrets will store base 64 encoded values. And currently, unfortunately, that's the biggest, weakest of secrets. You can easily decrypt the base 64 values. So there's no actual encoding yet provided by default. You need to work your way through. But there are options and possible solutions how to bypass the problem. So if we're having some problems with deployments like we did before, either you check the logs or you can directly connect to a pod and tweak it. But there's one problem with that. Since pods come and go, you don't want to modify any type of configuration inside of a pod, because if you're going to deploy the application, once again, new version comes up, there will be an error, and new pod will be spin instead of this one. That configuration will be lost. So if you actually want to, well, you can play here and see if it's actually modifying, but at the end of the day, you need to save the changes in the actual image that is being deployed. Because this is, if you have 4 replicas and you add some configuration variables into one of the pods, obviously the other 3 will not pick it up. That's why you need to save the environment variable either at the deployment configuration or inject into the image that you're actually trying to run. So if we now go back to our application, we'll try to search. Unfortunately, there's nothing going on. We can even check the network. What's happening on every single request? There are 3 requests happening on every search. We are trying to hit 3 different endpoints: text, video, and image. Obviously, we have text, but the biggest problem with the text endpoint is it does not provide any reasonable values currently. We can even invoke a curl against our text database. So we can double check if that's the one. The curl has to look like that. The remaining part is that counts. It's hard-coded in the application, so that should return as an empty JSON, right? But we expect some values, right? We would like to see some value. A is something that always works. So like I said at the beginning, we want to have the backend to be able to, we want to have the database to be filled in with some data. And for that, we are going to deploy the scraper. And the scraper introduces us to a new resource. A new resource is a cron job. A cron job is, like the name suggests, is a cron-like resource that allows to run some tasks in the cluster on some specified schedule. So how do you define the actual task? This is where the job resource is actually being used for. So all the resources that we use so far, the deployment, replication controller that I've mentioned before, all of them are meant to be running forever, meaning you start it once and it has to run always, right? That's the main idea. So with job that I wrote almost 2 years ago, job is meant to run your task once and that's it. It is meant to finish at some point in time, whether that will be minute, 2 minutes, 5 minutes, 5 hours, 10 days, doesn't matter. Its main purpose is that it will eventually finish. You can specify how many instances of your job do you want, how many pods will be running your job, obviously like with all the other resources, but that's the idea. And cron job is actually spinning up new jobs based on the cron format definition of the schedule that you have. So let's give it a go and create a cron jobs that will be responsible for feeding up our application. I've already went ahead and built a Docker image with the job definition. The job definition and the application, the scraper, is available inside of the GitHub. The scraper directory is where the application is available. You can easily verify that The application is very simple. So it's a very simple spider. All it does, it picks up a random word from a file, goes to Google, Googles that, and saves those links into the text database. Very simplistic, should not be any problems with understanding, I hope. So let's try to deploy such an application in OpenShift. Oh, there's information is quite important. Cron job is an alpha feature in Kubernetes and a technology preview in OpenShift. That means that the feature might change. I was hoping that it will get to beta by the end of 1.7 release, but since 1.7 release closes in a couple weeks, less than 2, I don't think I will be able to finish that one, unfortunately. I bet there's several people who are a little bit disappointed by this, but time. Okay. I haven't mentioned OC Run before, but OC Run is a very powerful tool. It allows you to run your application in multiple specified ways. In our case, I'm specifying that I want to run scraper will be the name of the resource created. The schedule clearly states that it should generate a cron job. We specify how often we will run every 5 minutes. We specify the image and the restart never. The restart is crucial over here because by default OC Run creates deployments or replica sets or application controllers which have the restart always by default. So if we don't specify that one, it will create a cron job resource with a restart policy always, and that will fail validation, which happens on every resource submission. You can give it a try, but like I said, that will fail. Like I said, cron job was created. We can describe the cron job. Why not? This is one of the features that is unfortunately Did I make a mistake or what? Oh, maybe I know what's the problem. Yeah, I was fixing that one just recently. Here's the entire definition of the cron job. And like I said, this is an alpha feature. And one of the reasons is that it is also not available in the web UI, unfortunately. So we need to wait for another couple minutes, actually a minute. And there should be a job created. The -w option at the end of OCGet stays for watch, which means it will watch for any changes to the job resource that are happening. So what I care about here is that I'm trying to get information about when a job is being created. We got one job created. And we want to go into the job and see, because unfortunately it will fail. We need to go to other resources, jobs. Sorry, no jobs. I wanted to go into pods because we want to see what's actually happening inside of the scraper. There's something wrong with our cron job, obviously. There's like gazillions of errors happening. And the one that is most important for us is that we could not list config maps from the cluster, from the API. Like I said before, we've created a config map inside of OpenShift to be able to reuse this component to get the information how to access the database. But by default, every single object that is running, be that a deployment, every single pod has a default service account assigned to it. A service account allows you to limit the access rights, the permissions that every pod has. And by default, these are very limited. There are three default service accounts that are created for us for every single project that we have. And we can have a look at what these are. Service account. These three service accounts are the builder. The builder needs to have the permissions to be able to push the image that it builds to the internal Docker registry, right? The deployer, on the other hand, needs to know how to modify replication controllers because it is responsible for creating those, and additionally needs to be able to pull the images from the Docker registry, internal one. And there's the default one, which only has the necessary rights to access the internal Docker registry, pull the image, and that's it. So for our use case, we need to create a new service account, and this is the recommended approach, that you don't modify the existing, but rather create a service account that is specifically used just for the scraper, cron jobs. So yet again, we need to go to the docs because there's already a command that we can use. And then again, we will use OC create service account. The scraper service account should be created. And then additionally, we need to assign the scraper a specific role. In this case, it needs to be able to view resources inside of my project. That's why I used add role to user. But the user is not a regular user, but rather a virtual user like a service account. Right? Normally, if you're logging in, you're being assigned a token, and you're using that token on every single request that you were working, either through CLI or the web console. And we need some sort of, we obviously don't want to hard code the user and password for the scraper, because that would not be super secure. But rather, we want to create a service account that is limited, that has a limited functionality. And that, in our case, we created one that has the ability to view the resources inside of OpenShift cluster, for which we are using OpenShift REST client. So now we need to specify that the cron jobs should use that particular service account for its purpose. So yet again, we reach out to OC. This time we will use OC edit, which allows us to edit the resource. Does anyone is scared of YAMLs? I just read a month ago when I was at KubeCon, I've heard that people compared YAML to assembly, which is, I hope that's not that bad, right? Like, YAML is readable, right? Yeah, okay, cool. Because I was on the side where, no, it's something that I'm using on a daily basis. So okay, we use OC edit cron job scraper. And there's the problem with the YAMLs is that it has a specific structure. It is hard to know how to use those. I personally have like a bunch of YAMLs ready to be used, cron jobs, deployments, or whatever, whenever I'm working with OpenShift. And the reason for that is I don't have the brain power to remember the structure of those objects, especially that they are changing so fast if you're working in the upstream. That's why in majority of cases, I'm using those handy commands such as OC create the resource name, and then I'm passing some commands, or OC new app, which will create all the resources for us, or OC run, which will do what will do that for us. But in this particular case, I remembered, and that could be easily checked. And let me show you how we can actually do that. And I learned that just recently. Aside from actually going into the YAML definition, because they are available in the official documentation, you can do OC explain. Not sure. Cron jobs is an alpha feature, so not everything is out there. So, but we can easily get information about a cron job resource. And here are the fields, since we know that we care about spec, template. There are information about each of the sub-objects, and you can go down the stack so to get to the actual field that we care about. Okay, I was close, but not quite right. Okay, I forgot the dot after spec. Service account name is the name of the service account to use to run this pod. This is more or less what we need, because a cron job contains actually a job definition, inside of which there is a pod definition, inside of which there is the service account name. A little bit complicated, but it's not that bad. So let's go back once again to the edit command. OC edit command will bring you the default editor that you have installed on your system. Not sure what that is on Windows, but I'm positive about Linux and Macs. So the service account name has to go right after security context. The service account name that we created was scraper. That's it. We can save the changes, and the cron job was edited, so that's fine. We'll do OC because we want to know where the next job will be created, which should happen in 2 minutes about. If you made a mistake, a typo, if there will be a problem with your resource, a validation error should pop up, and you will be brought up with the editor once again. And at the top, after the comments section, there should be a detailed information why your modification was rejected. Unfortunately, if you create a unknown field, the unknown fields are just ignored. So that's the only downside of using the edit. So if you figure out that it will say that it edited, but nothing will change, then might be that you have a typo. In those cases, it will just ignore, because it doesn't know how to match the field. It doesn't match the definition of the object, and it just ignores the new fields. We need to wait 1 additional minute. Are there any questions? Sure. So the entire workshop that is available as part of this documentation is available on my GitHub account. It's part of the talks 217 PyCon, and it's available there as ASCII docs. You can easily go through those. This is the scraper one. So you can just...
Is there a way to see jobs that are scheduled in the future from CLI?
No, because we don't schedule jobs for the future. What you will get information about is only what happened and not what will happen. Cron job is done by best effort. It's not 100% guaranteed that it will run. Additionally, there are use cases where because there's an option to specify, I'm running a job every 10, 15 minutes, whatever. But I'm giving the job just 1 minute to start. And if it's 1 minute above the schedule, it will not. It will skip this particular run until the next one. Additionally, so that's one thing that it will be hard to predict. The other one is that the cron jobs allow you to specify different restart policies. Those policies will influence how your job is being run, because it can either run concurrently, meaning that if the previous job is still running, the new one will be allowed to run. The other two policies are either I'm going to forbid running new jobs until the previous one is running, or I'm going to replace the old one with a new one. So there are three different possibilities, and based on that, it will be hard to judge when you actually want to run a job. Okay, it looks like we got the job running. And let's check the, of course, I did not want that one. Let's check the overview page. Of course, not overview, but I want to have the pods. Let's check the logs of the latest pod that just run. The logs are only there to know that it finally did something. So there's no error, and it was usually we can see that it tried to get unchristianness for whatever reason, and it actually saved some data to the backend. Like I said, the easiest way to verify that the application is running. There's no limit on, there's no limit on the amount of characters that you type in. You should probably do one, but it will be harder. If you specify A, you can clearly see that the text backend is actually returning S. The values does not matter. I know some of you are looking at those. I don't care about those. And hopefully every 5 minutes we will get more and more and more of those. So there's a coffee break currently. Go grab a coffee, and we will be back in about 10-15 minutes, I guess, to finish the image and the video part. So in the meantime, the cron job was able to kick in several times. And if I check the output, you can clearly see that there's more data that was provided by the cron job that happened in the background several times. So what's next? So far we've deployed the web front end, and we deployed the text backend, and we also deployed the scraper, which is responsible for feeding the data inside of the application. The two remaining pieces of our application is the image backend and the video backend. But going through manually through setting up the entire application is cumbersome. As you've noticed, it takes a while. You need to know some details about MongoDB images. If we will be using PostgreSQL for the image backend, you will need to know what are the environment variables for the PostgreSQL. And if you want to share the application that you built with somebody else so that he can easily deploy the same application on a different cluster, you need to have an option to share a configuration description. And additionally, we created a config maps with values for database credentials. And so we additionally want to be able to generate those values so that each and every single deployment will be actually unique with the credentials, and not like everyone will have the same app because they used my template. So what we did in OpenShift is, and something that we're trying to convince upstream to, is deployments. Deployments allow you to, aside from putting the entire definition of every single resource in one file, which is also possible with Kube, we additionally provide you with a mechanism to use parameters. Those parameters are like you can see on the slide, are regular values that I use throughout the entire template.yaml. And every piece of the application, every component, already has a predefined template.yaml. So whenever you will be playing with the app, you don't have to, on your own back home, you don't have to go through every single step like we did throughout this entire workshop, but rather you can give it a try and just deploy the templates. There's even a setup.sh file that will set it up, the entire app for you. But go back to the to the parameters. I'm specifying I want to create two MongoDB parameters. One is for user, the other one is for password. And I'm using curly braces with a $sign as a notification that this will be generated. And at the bottom of the YAML file, I'm specifying how the parameter will be generated. It uses regex similar format, in that I state that I want to generate an expression, and then from field specify how the generated field value will look like. In my case, this is 24 characters, small caps, small caps, lower, and numbers, and there it'll be 24 length, 24 characters in length. You can easily tweak that one if you're familiar, if you have at least basic familiarity with regex. You should not have any problems with understanding that one. The required field clearly states that this parameter is required, and upon instantiation, if there won't be any value, because if there is an option to deploy a template either from the CLI, and that is what we are going to do in a moment, or from the web console. From the web console reads through the template. It looks at which parameters should be filled in, and it either provides you with an option to replace those or auto-generate those. And eventually, if there won't be, but there will be a flag required, it will not go further without you providing the values for those. So, yet again, for our use case, we will use OC new app, but this time, instead of specifying the application source code, the builder image, and additional parameters, we will point it to the template file. So, yeah, it happened so fast. So, this is actually the video template. And as you can see, here are the parameters that it generated. The GitHub secret and generic secret is something that I did not cover yet, but I will talk about in a moment. And as we see, it created config map, build config, image stream, deployment services, routes, deployment services. Literally all the pieces that we covered and all the elements throughout the entire workshop so far. So if you go to the, let's check how the template actually looks like. It's a bit of lengthy file. Like I said, I've put a lot of comments in each of the pieces so that it can easily be figure out which part is responsible for which object. So the initial part is the usual descriptions of a template resource, and then you have the configuration, which is which is created as a config map. Then there's the build configuration, as part of which there are multiple triggers that I haven't covered yet, but I will in a moment. There's the source information, the build strategy information, where the application is being, where the final image is being pushed to. There are the image streams configuration. The deployment configuration would specify the strategy, the triggers that the deployment has, the number of replicas, because at any point in time, we can scale up or scale down. And I assume that you give it a try because there are nice arrows next to pods and see what happens. There are configuration change information and the full specification of the deployments for a MongoDB, along with readiness probes and liveness probes. The same applies for service configuration, route configuration, the database backend, and at the bottom of the file, like I showed you, are the parameters definitions. We are generating MongoDB user, password, admin password, GitHub secret, and generic secrets. Like, this is the parameters that we saw were generated. So in a similar fashion, we can easily deploy the image backend. Now, if we go back to our overview page, there will be tons of information currently. Oh, unfortunately, something failed with the build, but we can easily fix it up. Let's close the TextDB because we don't care. This is the thing that we already covered. Okay, the video DB is our video database, and that is running properly. Unfortunately, something happened to the build, to the video build. We can check the logs and see what failed. It failed pushing to the integrated Docker registry. It sometimes happens. I don't know why. There's some race condition in where we set up the secrets for pushing those. So the easiest in this case is to trigger a new build. That's what we will do in that case. It usually happens when we're smashing the platform with too many builds. And unfortunately, for some reason, the image also failed to push. And we will just trigger a new build because that also failed on pushing to the registry. And let's hope for the best. Yep, the video build succeeded for the second time. And the image build is currently running. So, so far I've covered only one build strategy that is available in OpenShift, which is the source to image, which means we take the runtime environment for any particular language. In our case, that was Python, which literally just installs pip dependencies and then just runs your application. And this is the source to image. But there are other possibilities how you can build your application in OpenShift. The other strategies available in OpenShift are Docker build, which is literally running Docker build, and as an input, it accepts a Docker file. And the other one is Jenkins pipeline, which sets up a Jenkins for you. And using the Jenkins pipeline plugin, you can specify the entire flow how your application will be running, meaning you go through a build phase, then you go to a test phase, you do a test deployment, and then there's you can all the way go to requiring a manual I accept step. Somebody from, I don't know, let's say QE department needs to say, okay, this is fine. So there's a lot of flexibility around how you can provide your pipeline, your deployment pipeline. And that was the second, third, fourth build process is a custom build. Custom build is very similar to S2I, that it allows you to specify the builder image, but there's no restrictions how the builder image looks like, so you can create any type of builder image that can be capable of building either RPMs, zips, archives, whatever you're comfortable with or your process requires, and push that one to a remote location of your choosing. So there are these are the different build strategies that you can use in OpenShift. Why we are pushing towards source to image is source to image is the safest of the other ones. The reason for that is Docker build requires root access to the Docker socket, and the same applies for the other one. Oh, well, except for Jenkins pipeline. Jenkins pipeline is on the safe side along with the S2I. So in majority of environments, only the privileged users will be able to invoke Docker build or the custom builds. And actually, if you go to OpenShift Online, these two will not be available for regular users for the security reasons, because it literally requires root access to be able to get to the Docker socket and invoke Docker build command, which is something that you don't want to allow. And additionally, the good thing about using source to image or Jenkins pipeline is that you can specify, or as a company, create a unified runtime environment for your application in such a way that users or developers only care about actually building the application, and the operation team is then responsible for providing the builder image, because they have some requirements, either that security, either that will be a security requirement or some organizational requirements for how our applications are being run. We can bake all those information inside of the S2I builder image and provide the developers with them, because in most of the cases, developers only care it has to run. but they don't care about the environment which is this running in. So source to image allows that flexibility around the stability of what is being run. And the other thing that I haven't mentioned as part of the introduction to the build was the triggers. I've already talked about config change triggers and image change triggers. Image change triggers fires up a build whenever a source build or input build, like for example a builder image, will change. We can trigger automatically a new build because of that. But the third triggers that I did not cover are source code changes triggers. So OpenShift, and we can go to any build configuration. OpenShift allows you to set up a GitHub or generic webhook URLs that will trigger a new build. This means if you're familiar with GitHub and you have your source on GitHub or whatever other source repo, you can set up a webhook, and this is the URL for that you need to paste into GitHub webhooks configuration. And this means that whenever I push changes to my repo, GitHub will notify OpenShift that, hey, there are new changes being pushed to the repo, and that in turn triggers a new build happening. And since deployments will have the image change triggers configured, that will trigger the deployment. So in a very simple way, with a single git push, I can trigger the entire pipeline from build to deployment and have my application up and running within a couple minutes, depending on how long the build process is taking. Does that make sense? Are there any questions? Well, the webhook specification is properly described in the documentation. The GitHub webhook URL is literally designed to work with GitHub. The generic webhook URL is very similar in the form how the description of the change, what that's the expected change description looks like, but it is very easy to set it up with GitLab or any other source code repos. I know that generic was easily working with GitLab. So that covers the builds part. And now let's go back to deployments once again, because like I said, there are a couple deployment strategies available in OpenShift. And if some of you already clicked through the workshop documentation, through the workshop docs, at some point in time there was a link to colorful deployments, an article that I wrote some time ago about how to implement different deployment strategies on OpenShift. I'm going to give it a try and show you how you can do that one easily on OpenShift, because that's pretty nice to see. Let me go back quickly to where my examples are. I need to figure out where I have those. I think I have those here. So I'm going to create a new project, or maybe they already do that one for me. Yeah, they do. Okay. So I'm going to view all my projects. This basically creates a blue-green deployment. Are you familiar with the blue-green deployment? The idea how to set it up? Yes, no? No, okay. So the blue-green deployment, the idea is I have two identical environments. One is the currently running my application. Like literally entire environment is in two copies. And I'm currently running one environment with my current applications. And in the meantime, I'm bringing exact same environment with the new application. I'm running all my tests, everything, making sure the application is up and running. And at some point in time, in front of those two environments, there's a load balancer. The load balancer tells the entire traffic should go to one of the environments. Let's say this one, because this is the current one. In the meantime, I'm setting up the new environment over here. And whenever I'm satisfied with the new version, because it went through the entire testing process, and the QE say it's green, all you need to do is make a flip on the load balancer that the entire traffic from the old one goes to the new app. The benefits of using this approach is that it is almost instantaneous, switch from one environment to the other one. There's no downtime. Users will be automatically redirected to the new environment, so it's win-win basically for everyone. There are some downsides of that, because the transaction that started on this environment will just get will be lost during the switch to the new environment. So that's one of the problems, and basically all the deployment strategies that I'll be showing off will be struggling with the problem of lost transactions. But the good thing about that one is if suddenly you discover that the new environment did not went through one of the checks or is suddenly failing, it is very easy to roll back to the previous environment. And this is what we will do here with our application. So we have our blue-green environment. We have a blue deployment on the left side, and that blue deployment is actually running three replicas of our application. Obviously, the also biggest advantage of blue-green deployment is you need to have two environments, identical environments, so that you can switch from one to the other one. Obviously, this costs money, right? Because you literally have twice as much of the hardware or VMs that you need to run. So, okay, let me quickly go. I need to. Oh yeah, I know, because probably the get is trying to access my local environment, which is not the case here. But we will fix that one quickly. So where I'm heading with this is that, okay, we have the blue working. Okay, I need to go once again to my talks examples, and am I missing something here? Blue application deployments, blue-green. Okay, I thought I missed something. Okay, now that it refreshed, this is the part that I was missing. So the current state is the entire traffic is going to this environment, right? Simple as this. If I click to this, which is sort of what I'm doing over here, because I'm hitting the entire time this, I'm hitting the blue environment. All I need to do currently is to modify the load balancer to switch to the other one, to the other environment that I set up in the meantime, that went through the tests, etc., etc. So I need to go through routes, and now I need to edit the route. There's a nice switch. And that should be reflected on the overview page. And yeah, that's what happened, literally. It's that simple how you can, cover your traffic. So that's one thing. That's one possible option. The other one is a canary deployment. Who knows how canary deployments work? Anyone? Yes, no? No? Cool. Canary deployments are very similar to blue-green in that there are two environments. But what is different is that we have one big environment being the current one, and we deploy the newer version of the application only in a fraction of the original deployment. And only a fraction of our traffic is being directed to the new environment. For using a canary deployment, it is good to have some sort of mechanism that will be deciding how much of the traffic is actually directed to one or the other environment. The most advanced tracking or router that I know of that is available is in Facebook. I can't remember the name currently, but if you check out the article, there are links to, I think, a talk from Facebook about their tool. And literally, it is written in such a way that it easily allows them to configure that the new version of the application, it is available only for women's, only for men's, only for teenagers at the age of 16, 18, etc., etc. Based on all the information they have about the users, they can easily decide that this new application, this new feature in a Facebook will be only available for a certain group of users. So that is the most advanced feature toggle. That's the name, official, but the actual name for Facebook I don't remember. The feature toggle is the most advanced feature toggle is at Facebook. So in our case, we need to go to Canary. And again, I've created two environments. One is our production environment, one is our Canary. And all we care about is that we want to push to our Canary only 10% of the traffic that we have. So, okay, let's do the get once again, because if I remember correctly, there's the get as well. We need to tweak the get in such a way that it actually will be hitting the right endpoint and not the other one. Okay, that is hitting actually the production. Of course, the application routes. We need to modify the route once again, and all we care about is 10% of the traffic should go. It's that simple. Now every 1/10, or I think more than 1/10, should hit the Canary. That's what I remember. It basically looks at the service and the amount of pods that are behind it, and additionally, based on that and the amount of traffic that is actually being directed at certain pods, it will do some crazy calculation and decide when it should hit the Canary. And it should hit at some point in time. Hopefully. Or not. Just because not. Of course, it won't. Well, we can put more traffic then. I think I explained in the article more or less the math behind this. Let's increase the frequency, the probability of hitting that endpoint. Will it? Oh yeah. Now it hit every now and then. But this is the reason that this is the limitation of the router that we have. It is perfectly nice to divide the traffic by percentage, but like I said, if you want to have some more sophisticated way of traffic direction, you need to have some sort of feature toggle, and based on the information that you have from the users, then you decide how often they will hit one or the other environment. And the last one is showing off the default deployment strategy that we have in OpenShift, which is the rolling. Because like I said, there are three possibilities, how you can, three possible strategies for OpenShift for deploying applications. The default one is the rolling one that I'll be showing you right away. The second one is recreate, which is literally kill the old one, create a new one from scratch. The third one is a custom deployment, which means you provide us with a deployer image which knows how to deploy your application, and you can literally code what the deployment process, if it's somehow specific to your application, you can put that one into deployment, and that will be using the custom deployer. We are currently looking into the default deployment, which is the rolling one. The rolling one currently has 9 instances. As you might figure it out from the name, rolling deployment, it will roll new version of the same application slowly, one after another. So I need to be fast. So there are multiple options how you can actually configure the rolling deployment strategy. By default, it will replace one by one in my current example. So at any point in time, there will be 10 pods running my app. It will be always, in the first case, it will be 9 of the old one, 1 of the new one, and only when the one is passing the readiness checks, this is where the liveness and readiness checks come into play and make sure nicely that the application is running correctly. If it passes readiness checks, only then it will actually kill an old one from the previous version. And it will slowly move from one version to the other one of the application. This is probably the coolest feature that you can have at any point in time, to slowly switch from one environment, from one version of application to another one. And this is the default deployment strategy in OpenShift. Okay, are there any questions? Yeah. So the service which is responsible for actually forwarding the requests to all the new ones, by default, it will remember which pod was actually serving your request. It is part of the cookies. It is remembered. And user that is already tied to a pod will always return to the same pod. If you won't hit the same pod when you're interacting with the application, only if you have cookies disabled or you're not saving cookies. If I'm going through, that's the reason I'm using curl, because otherwise I'll be hitting the same environment all the time. If a pod goes away, then obviously you will have to hit to the new one. So again, the problem of lost transactions happens here. It literally is a problem with all the deployment strategies that I talked about so far, because you're switching from one environment to the other one. So you need to be aware of that one and either be prepared for that one or try to mitigate the scope of the problem. Additionally, and this is the basic requirement for all the rolling type of strategies, is your application needs to be written in such a way that at any point in time it has to work with the new one and the old one. Meaning, if you have AB rolling or whatever, and you have a backend database, the database needs to be written in such a way that there's no field disappearing magically. You need to make the upgrade process smooth, and the app has to be able to acquire those new fields appropriately. You need to you can't do, you need to incrementally change your application. You can't do, magic, no, okay, I'm gonna drop this field. No, that's not how you can do it with the rolling upgrades. Are there any other questions? Okay, so this is where we slowly close the workshop. There are a lot more resources available in OpenShift or Kubernetes that I did not cover so far. And let me talk about it a little bit shortly about each of them so that you can be aware that there are other approaches how you can deploy application. So first of all, the topic that I did not cover is persistent volumes. Like I said, pods by default come and go. They should be ephemeral, immutable, because at any point in time, if you're scaling your application up and down, a new pod will be created. So the image has to be the same for all of them. And if you care about deploying, for example, a database, you need to have a mechanism behind the pods that will make sure that whenever pods come and go, they still have the same data behind it. And for that, you will use persistent volumes. By default, the volumes that are mounted inside of every pod are ephemeral, which means when the pod is gone, the data is gone with it. So if you care about the data, you use persistent volumes. And that will be, in most cases, that will be for database backends or something like that. In my case, literally, if I kill the text database, which I can show you easily, or you can play in your own environment. If you kill the database, the text database, the data will be gone. It will be brought up immediately for you because that's the role of the replication controller that is behind every single deployment. That's the contract of our deployment. There has to be one running pod of the application. But there's no contract for this data should be persisted. This is why you need to literally configure persistent volumes. So that's one thing. The other thing is quota and limits. The environment that you are playing with currently is not quota in any way, which unfortunately caused us, at least myself and a friend of mine, problems once, because somebody during the workshops scaled up his application to 1,000 instances, and the entire environment literally went down because it was DDoSed from inside. But it is an intentional approach because we don't want to limit people. There are different types of applications that we are trying to deploy during workshops, and we trust that people will be mindful when working with the environments. But obviously, if you're running a production environment, especially if you're enabling those for external customers, like what we do in OpenShift Online, you want to create hard limits and hard quota for the resources. This is what I was talking about, that OpenShift Online provides you with 1 GB of memory and 1 GB of memory storage. Additionally, there's a limit on the number of CPUs that you can use. What you can do on your side, though, is that by default, if you don't specify any resources for your application, remember when we were creating a new application and we went through the advanced pages, at the bottom there were limits for the applications. If we know that our application is fine with running, I don't know, half of a CPU, or there are, how you can calculate those, it's pretty reasonable. You can specify, you can lower the limits, and this way be able to run multiple applications at the same time, right? Because not every application will need 1 CPU and 500 megs of memory or 1 gig of memory. Python should not, definitely. So you can limit those, you can set those limits to a reasonable amount, and based on that information, your quota will be decreased on every new application being deployed. So that's one other thing. The secret I shortly mentioned when we were setting up the config maps, which is the right way to actually store confidential information. We are hardly working upstream currently to make sure that the secrets are encoded and stored securely. Currently, like I said, it is only base 64 encoded data, which is so super simple to decode, right? Um, then two other interesting deployment resources. Go back. Two other interesting deployment resources. We use deployments, which main purpose is to be able to track the previous deployments and specify that I want to have this many replicas of my application running at any point in time. But there are other requirements for running some applications, and this is where daemon sets, for example, come into play. Daemon sets allow you to run a pod on every single node that you have in your inside of your cluster. Can be that on every single node or on a specified group of nodes that you have. So, for example, some kind of a metrics or logging you want to have running one of instances on every single node. This is where daemon sets come into play and are very handy to run this type of application. The other one, I was talking about databases. Databases are by default a stateful applications. All the things that we covered so far, the fact that this is ephemeral, they come and go, this is literally designed for microservice architecture. You don't care about how many of them are running at any point in time. You just care that it is there, the amount of the resources that you specified. Whereas stateful sets are providing you with unique identity for each of the pods that create your stateful set. In the majority of cases, when you're deploying databases, you need to make sure that there's 3 instances, that each instance has a unique ID, and that ID is being maintained throughout the entire lifecycle of the application. This is where stateful sets come into play, because they will maintain, each of the pods will have unique identity in the set, and that will be maintained throughout the entire lifecycle. It's not like with deployments, when there's 3 pods in it, and one of them dies, a new one will be brought up. Nor the name will be the same, nor anything. Meaning that the data will be different because we'll use just ephemeral for that, or things like that. Whereas for stateful set, even the pod identity, the name of the pod, will be identical like the one from previous. This allows for any type of master-slave replications or similar to work properly. There's a pretty cool demo from Josh Perkos, who is using stateful sets to deploy PostgreSQL replication environment. So it's worth having a look. There's also horizontal pod autoscaler, which, based on the information from the metrics, allows your application to be deployed, scaled up or down. So you can set up an automatic monitor that will look at your application. You specify rules upon reaching which the application should be scaled up or down, and you can easily monitor and respond to the traffic that your application is experiencing. There's another resource that I didn't brought it up, but I was talking with a friend from the back that allows you to automatically add clusters, nodes to the cluster. If I remember correctly, that is called vertical autoscaler or something like that. And that again allows you to automatically respond to a bigger traffic coming to your cluster, which is pretty cool, right? And I think that covers all the things that I wanted to talk about. Let me close you with reminding that The OpenShift origin is is the project that I'm working on a daily basis, and this is where you can get the binaries to either run OC cluster up locally, and I highly encourage you to do so if you want to play more. I had an information from Graham that he will leave the environment for you to play a little bit more till the end of this day. So, like I said, be mindful about the resources, but you can give it a try till some more time today, and later on, either try OC cluster up, try Minishift, or OpenShift Online. There's a new installment from Red Hat Summit not that long ago, which is OpenShift IO, which is totally mind-blowing. When I saw that one, I wasn't even expected that thing coming out, which is a development environment for planning, creating, and deploying hybrid cloud services using OpenShift. You can, I think there's a demo on YouTube showing off how OpenShift IO works. There's OpenShift Dedicated, which allows you to, which literally you pay Red Hat to run the OpenShift environment for you, or there's the OpenShift Container Platform, which is the paid version of OpenShift Origin that OpenShift provides. There are two books available about OpenShift: OpenShift for developers and OpenShift for operators. Graham was the author of them, and you are going to receive each of one of a copy. So just after the workshop, come to the front. You're going to get a OpenShift USB key and a book. But you can also get those books for free online. There are links in the tutorial in the workshop. So I think that's pretty much from my side. Do you have any questions? No, I didn't have Katkoda. I did not, or I did have. Oh yeah, there is. There's also the interactive learning portal. Just go to learn.openshift.com, and that will cover some of the topics that we have in this that we covered in this tutorial as well. Are there any questions, topics, something you did not understand, or anything like that? I also will be throughout the entire PyCon conference, either at the swag booth or around Red Hat booth, or just look for my Red Hat. I'll be wearing that throughout the entire conference. If you have any questions, doubts, or you slept with some problems and you want to talk about, I'll be happy to answer all your questions. There's one last final request from me. If you could go through the survey, the organizers want to know how bad I did the tutorial. So thanks very much. Hope you like it. Exactly the same as the user you've used. So go ahead and download the OC binaries for your stations and try to log into the OpenShift cluster. I already have one.
I know, but not for the people who don't.
Who doesn't have? You have that one for Mac? Graham, the other one is for Mac, I guess. I can build, in the worst case, I'm going to build the binaries. It will be definitely faster than the 20 minutes downloading part. Okay, as soon as you get the binary, I'll try to move forward slightly so that we are able to not to stop in a moment. So for those of you that already have the binaries, you can try OC version. That should give you the information about the current version of the OC binary that you have installed. In my case, it's running OC v1.5.0. And that will be probably the same version that you should be running. It both tells you about the version of the Kubernetes that we have behind the OpenShift and the OpenShift itself. If there are any questions at this point in time until we get the OC binary running, I think we can answer them. Are there any questions, doubts, problems, aside from network? Does anyone need the Linux one? I still have the key for the Linux one. Don't be afraid. Okay, cool. Don't be afraid. You can. That's Windows. Cool. Don't be afraid to ask questions. For the most active attendees, I have some rewards. So I'm not biting. I really, really like for you to actually get something from the tutorial. And although I'm a little bit stressed, okay, that's the laugh that I needed. Thank you. Okay, I'm going to give you additional minute or two, and then we will head off to actually trying to deploy the application. Or maybe in the meantime, since I'm waiting, the next piece of advice that I can give you is we are providing you currently with an environment where you are able to run the OpenShift app. If you're, on the other hand, would like to give it a try on your own, at home, at your own laptop, there are three possibilities how you can run OpenShift. First of all, there's OpenShift Online, and that was announced about 2 weeks ago during the Red Hat Summit in Boston. That OpenShift Online went public officially, so it went out of the dev preview, which it was. So that means that anyone can get an access to OpenShift Online. We provide you with a 1 gigabyte of memory and storage for running your application. Unfortunately, the application that I created today is a little bit heavier than that, and I failed deploying my application very fast. The other two alternatives, which you can use locally, is the Minishift. Minishift is a VM instance with pre-configured environment, or additionally, there's a development option, which you can go through just taking the binary and do OC cluster up, but please don't do it right now. The reason for that is OC cluster up downloads Docker images that are needed for running the OpenShift instance, and it just literally runs it runs all in one, meaning both master and node runs as a Docker image, and additional options, and it all runs in a Docker environment. That's why I'm not asking not to do it right now, because you're going to kill the network entirely. And we don't want to do that because we obviously want to finish the workshop. So I highly recommend that one if you want to give it a try at home. Probably the OC cluster up is the simplest one that you can come up with. Once obviously the first OC cluster up will take a little bit time because it needs to download. If I remember correctly, there are 3 images where you will put your all application. It allows you to manage who has access to which namespace, where all your application will be running. And within each of the namespaces, which in OpenShift is a project, and I'll explain why OpenShift decided to build on top of namespaces in a minute, we will be actually running our applications. So the smallest piece of unit that is running in OpenShift is the pod. The pod is, in majority of cases, one-to-one mapping with a container, but it doesn't have to be. A pod can be one or multiple containers, but from my experience that I was deploying different application in OpenShift, in majority of cases, it is always one Docker container is one pod. But there are possibilities that you can have multiple containers being part of one pod, and that reason might be either some kind of monitoring that you can have along with your pod, along with your main application, or some additional diagnostic tools that you can deploy together. So the pod is the smallest unit. The second important piece of the entire puzzle is the labels. Labels allow grouping resources together. We put a label on different resources, and based on that, we will be able to figure out that this group of pod that has this particular label will be creating a service. So a service, on the other hand, is a stable point for accessing your applications. Like I said, pod is the smallest unit, and they are brought up and down as needed depending on how many replications of your applications you want to have, how many instances of your applications. So they will be brought up and down, and additionally, you can scale it up and down. And if a pod dies, a new one will be created in its place. And the service will provide always stable access point to all the backing pods. It'll be so much clearer when we will be deploying our first application. So hopefully that will make sense at that point. So we covered the pods, we covered the nodes, labels, and an important also information along with labels is label selectors. These allow us to define how the selection process is happening through the labels. And one final piece of information is the replication controller. Like I said, pods can come and go, but manually managing the pods will be cumbersome. That's why a replication controller is responsible. This is the first controller that you will be working with. Its responsibility is to make sure that at any point in time, there are always this many instances of your applications, this many pods of your applications running at all times, always. So that means if we manually add a pod that will be selected as part of this group, a replication controller will pick that, oh, this does not belong because we want to have 3 and then suddenly are 4 running. It will kill one of those pods. And throughout his life cycle, if it figures out that there's not enough pods on the other hand running, it will bring up a new one to replace the one that died. And I'm hoping that I covered all of the places. Oh yeah, there are 2 other resources that are important and will be used throughout the rest of the workshop, which is the route, which allows exposing services to outside world, because services only expose the application inside of the cluster. It does not go beyond that. And the event provides you information about errors, problems, warnings that are happening in the cluster with your resource. For this workshop, we will be using a environment that Graham kindly provided to us and the entire OpenShift evangelist team. You've received the URL for the server. I've also asked yesterday in a note to download OC client. I do hope that you managed to do that one. If not, in the next section we'll get to that one in a moment. you will be provided with the links to the OC client. We will be interchangeably using the web console and the OC client binary. The reason for that is the web console provides nice user interface, but unfortunately it's usually a little bit behind the OC client, and that's because everything that is done is usually done from the command line. That's why the web UI team has to catch up with so many moving parts at the same time. You got the user name, and the password is exact source container orchestration platform, which in the simplest term means you have a Docker image with your applications, and Kubernetes allows you to nicely run your application in the cloud. That's the simplest possible information. And what OpenShift is actually an enterprise distribution of Kubernetes. Similarly to what we have a Linux, and then there are different distributions like Red Hat Enterprise Linux, there's Fedora, there's CentOS, there's Ubuntu, there's Arch Linux, or whatever other. Each company adds some nice bits to its distribution, and on top of that builds his product. This is how OpenShift was born. So let's go quickly through the OpenShift architecture, because that's probably the easiest way to understand what both Kubernetes and OpenShift is. And although I think I missed one thing from the previous slide. Let's go back slightly. Give him some time. I had a nice picture down that session, which depicts the differences. So, as I said, Kubernetes is the actual mechanism responsible for managing your containers, for scheduling them on nodes. So what OpenShift adds to that is the entire platform as a service capabilities that we already built into OpenShift previous versions, and we brought up this into the container world. So that is the builds, the routing layer, and the packaging. Okay. That's the picture that I was missing. Give him some time to load. Okay, so the bottom layer is obviously their operating system. OpenShift or Kubernetes can run on any kind of environment that you can think of, be that a bare metal, be that Amazon, GCE, or on-premise. On top of that, there's an operating system. In my picture, that will be RHEL. And the blue boxes, the 3 layers of blue boxes, this is where the Kubernetes is, which is container management and scheduling part of the entire stack. Whereas OpenShift, as I said, is the build platform, the deployment operations, although we managed to upstream several of the deployment capabilities to Kubernetes. The service catalog and the self-service, which you will be working with through a web console. Okay, now we can go to the architectural land. And of course, the web is not cooperating. Okay, so the 2 most important components of every OpenShift or Kubernetes clusters is the master and nodes, and that will be shown in the picture nicely. The master is the brain of the entire cluster. This is where the API server that you will be playing with is placed, and additionally, all the controllers which are responsible for going through the life cycle of each of the resources will be are provided. And the other part of the stack is the actual nodes. The nodes are the compute resources for the cluster, which is where the actual application is being run. And obviously, you can have both of the nodes will be the thing that you will have in as many number as you are comfortable of, or how much you need. And the master node is can be easily set up as a full high availability place. So that is the two most important pieces of the OpenShift. So how does the entire thing works? Okay, now we have half of the picture. The other half shows pretty much the same thing. So on the left, we have the master that I talked about. On the right, there are nodes. We have three. The three are yet to be shown in a few seconds. And there is a routing layer, the persistent storage in the back. And I think I remember that's the majority of the pieces. So before we move forward, I would like to introduce a few of the terms that will be necessary throughout the entire rest of the workshop, and then that I will be using in the workshop, and so that you can feel comfortable with. So the most important piece in the in OpenShift and Kubernetes world is the namespace. The namespace is a grouping primitive that allows you to put all, well, it's not a grouping primitive, it's a place where you will Folks, I'm going to give 2 more minutes for the latecomers, and we will start shortly. Hey, welcome everyone. Is there anyone who does not have a user and password, did not get a card from me? Okay, perfect. So we're here to talk about effectively running Python applications in Kubernetes and OpenShift. But before we get to that, let me give you a few questions. I want to figure out how much you know. How many of you heard about Docker? Awesome. How many of you heard about Kubernetes? Awesome. How many of you heard about OpenShift? Awesome. How many of you use Kubernetes? Okay, and by the end of this workshop, that will change significantly, I hope. Okay, let me catch up with the 2 new persons. Hey, welcome. So throughout the next 3 hours, we are going to create a Python-based app. And the entire workshop and the materials for the workshops are available under this URL, tutorial.apps.pycon.pixie.io. So either you can follow me talking and going through the presentation, or if you're comfortable, you can just read and go by yourself following the documentation. The documentation is descriptive enough to go through the workshop, and additionally points to necessary documentation pieces in Kubernetes or in OpenShift, whereas I'll be explaining in details every single piece of the software that I'll be deploying or working with, or helping you how to debug applications running on OpenShift. So whichever option you prefer, you're fine to do. If you have any problems, questions during the workshop, just raise your hand, or you can ask the questions, and I'll either come by and help you with the problem, or Graham will help me, or we'll try to debug together the applications. The new 2 persons, welcome. Here you go. And you're the other one, right? I think we're still missing couple people, but okay. So let's get this thing going. For those of you that know what a Kubernetes is, okay. Thanks. So Kubernetes is basically an open